Welcome, everyone. My name is Daphne Lei. I'm the Director of Illuminations, Chancellor's Arts and Culture Initiative. Illuminations aims to provide students meaningful exposure to art and culture, regardless their majors. So we especially encourage interdisciplinary dialogue among different disciplines, such as this one among arts, sciences, and humanities. So today's event, the major event, will be a conversation forum with a conversation with Dr. Samuel Ting today. And I have the distinctive pleasure to welcome him today. Dr. Ting will have a conversation with me. I'm a professor of drama, and Yong Chen, professor of history. So today's event will be from an arts and humanities point of view, and he will be talking about his Asian/American journey. And since we are here in humanities, we also have the distinctive pleasure to have Professor Terrace Miller, Dean of Humanities, to say a few words to welcome Professor Ting.
It's wonderful to see everyone here. It's an amazing turnout for this wonderful event. I am so pleased and honored to welcome Dr. Samuel Ting to UC Irvine and to the School of Humanities, where we will hear him present to our audience. Dr. Ting has lived a life of scientific inquiry and discovery, achieving breakthroughs in understanding the fundamental physical bases of reality, including the discovery of new subatomic particles and the explication of their properties. Both his peers in physics and even scientific laypersons like myself can recognize the magnitude of his achievements and their significance for the advancement of human understanding of our world and our universe. There's another story to tell about his trajectory, which is that of his eventful life and its unfolding in a wide span of history across multiple countries, including the United States, China, and Taiwan, a story of immigrant life, refuge from Chinese communism, and return to the United States for study and his scientific career. There are such immigrant and exile stories in many fields of knowledge, including very prominently in physics, which saw the convergence of many great physicists in the United States in flight from repression and war, starting in the 1930s and 1940s. Dr. Ting's story also reminds us that this enrichment of science and more broadly the United States universities by people from all over the world continued after World War II and continues to this day. I'm particularly pleased to host this presentation today in the School of Humanities, as I think it is exemplary of the collaboration and dialogue between our various disciplines at UCI, including between the humanities, arts, and the sciences. It is safe to say that there would be few people in the School of Humanities who could follow the mathematical language of Dr. Ting's contributions to physics, but there are many who help us to understand the historical, cultural, and linguistic context of his singular experience and story. And each of us at UCI, whatever our disciplines, as researchers and as educators, shares an uncommon commitment to the advancement of knowledge and to the enlightenment of future generations. It is in that spirit that I offer Dr. Ting my most heartfelt welcome to UCI and the School of Humanities. And now I will share the podium with Dr. Jonathan Fung, Professor of Physics, who will introduce Dr. Ting and say a bit more in detail about him.
Well, it's my pleasure to add my welcome to Professor Ting and all of you for this event. I'm sure it's going to be a fantastic conversation and also a time of Q&A. My job here is to just provide a little bit of context to the event. So every year here at UCI, the Department of Physics and Astronomy invites an extremely distinguished scientist to come and visit as the Rhinus Lecturer of the Year. Those of you who have ever taken a UCI tour probably know who Fred Reines is. Fred Reines is one of the most distinguished faculty members we've ever had on this campus. He discovered the neutrino, which is a fundamental particle and essential to understanding not just physics, but the cosmos and the universe. And he was also founding dean of the School of Physical Sciences. And so he had a large part to play in the bringing up of UCI from this upstart new UC campus to its present state right now in the ranks of some of the elite research universities in the country. So this year, we have the great pleasure of having Samuel Ting, one of the most important physicists of the last century, as our Reines lecturer. As you'll hear a little bit already, but as you'll hear much more of, his life, his personal journey is the stuff of legend. But let me just say a few words about his contributions to physics. So I'm in the School of Humanities, so let me start with this. You know that matter is made up of atoms, right? We're all good with that? So in atoms, there's a nucleus, which is a bunch of protons and neutrons that are bound together. And now we're getting to the stuff that you might not know. Protons and neutrons are actually made of something called quarks. And this has been established, this is a fact. There's two quarks, up and down quarks, that make up basically all of nuclear matter. Professor Ting discovered in 1974 an entirely new quark, entirely new form of matter called the charm quark. And it'd be hard for me to explain how revolutionary this discovery was, but let me just say, people who were working in the field at the time can remember the hour that they heard this news. It's kind of like the 9/11 of physics, but in a much more positive way. So this discovery was so spectacular and so immediately, obviously right. It was basically awarded the Nobel Prize as soon as possible, which was in 1976 when he received the Nobel Prize in physics. After that, he went on to do many other things. We won't have time to recount them, but just to give an example, recently he's been the lead and principal investigator on something called the alpha magnetic spectrometer. This is a multi-billion-dollar particle physics experiment that has been launched into space. So you might know there's something called the International Space Station that goes around the Earth once every 90 minutes. If you want, at night you can even see it in the night sky. It looks like a fast-moving star. On this quote-unquote star, there is a physics experiment which was led by Professor Ting, and that experiment is observing the universe in completely new ways, and we're basically changing our understanding of the universe and where we live. So that's some of the things that he has done. I won't delay his talking about them himself anymore, but let me just at this point welcome then to the stage. As Daphne mentioned, we have two very distinguished professors, one in arts and one in humanities, who will start the conversation off with Professor Ting. So Daphne Lei, you already met, who's a professor of drama and also associate dean in the School of the Arts, and then Yang Chen, who's a professor of history and also an associate dean in the School of Humanities. And so let's welcome them and also Professor Ting to the stage.
Oh, that's right. That's right. Let's move it. No, you have to be in the middle.
Yeah, you have to be. Is it on? Yeah, Professor Ting, welcome to UCI. You have such a amazing life. You were a global citizen or transnational traveler before such terms were even invented. Could you tell us a little bit about your early experience crossing the Pacific, recrossing the Pacific, and also crossing the Taiwan Strait? Just a little bit of your early life.
My first trip across Pacific was probably March 1936 from University of Michigan Hospital, where I was born. Take the train, according to my mother, take the train to Los Angeles, and then took a ship to, I think, somewhere in Japan, and then went back to China. That was my first trip. But nowadays, I've done so many trips. My latest trip was only a few days ago, from Geneva, Switzerland to Los Angeles. So in between, I had no idea how many trips I had. I have a lot of frequent flyer miles. But unfortunately, most of my trips are decided in the last minute. Okay. And so it's not too useful for me.
I'm just so excited. I don't know about you, but how often do you get to sit next to a Nobel Prize winner and also get to ask questions? Okay, thank you again for your time. And so you were born in Michigan in 1936, and
Yes.
then your parents took you to China right away. Do you know the reasons why they went back to China in 1936 after their education in the U.S.?
When they took me to China, I was a few months old, so I had nothing to say. And I think both my parents think they are Chinese. And at that time, there's tremendous turmoil in China, particularly with Japan. And so they said they want to go back to China. It's just like in many countries, like in the World War II, many people want to go to Israel. At that time, many Chinese want to go back to China. I suspect that's the reason.
Were they students?
They were students. They were married there, and I was born in the hospital, university hospital. And they both could have stayed, but both decided no, they want to go back to China.
And fast move forward. You I think in 1948, you left China and went to Taiwan. And as a 12-year-old young person, what was your first impression of Taiwan? In one of the interviews you did with AIP, the American Institute of Physics, you mentioned your memories of tropical fruits, such as I don't know, guava and papaya, right? The kind of foods that someone who was from Shandong and then went to live in Sichuan province during World War II, the kind of food that you never tasted. So what's your overall impression of Taiwan upon your arrival there when you were 12
I
years old?
think I arrived in Taiwan in, must have been December 48, probably 6th of December. That's a long time ago, so I don't remember exact date. And my mother and I took a walk on the street, and I noticed there are many kind of fruits, and I've not seen before. Okay, papaya, banana, and guava, all kind of fruits. Yeah. And people, local people were very friendly toward me.
In 48.
In 48.
But things would change fast after that.
No, I think I was in Taiwan from 48 to 55, 56. And during this period, everything was peaceful. I enjoyed my stay there much better than stay in China, because during my stay in China, there's constant airplane visit from Japan. Okay, they come to Chongqing to dropping bombs, and then there's the communists took over. Yeah. But in Taiwan was finally have time to go to school.
Yeah, I remember some of my parents' memory were similar, because my mother was from Sichuan and my father was from Fujian, and they both arrived in 49, so a little bit later than you. And then they talked about, wow, all the bananas and all the fruits they have never seen before. Yeah, what did you speak? Did you speak Mandarin? Did you speak different dialect at that point?
I speak Sichuan dialect.
Yeah, okay.
Because
Which
I
is
grew up in
similar.
Chongqing.
Yeah.
So when I was in Taiwan, eventually I managed to learn the local dialect.
Yeah.
But now I've forgotten all of them.
What was your education in Taiwan like? You talked about that was kind of finally you have a sort of formal education. You settled down a little bit. What was your first physics class, for instance? If you remember.
I definitely was not the best student. I was very interested in Chinese history. And so-called interest, according to me, is you have a minimum amount of time to read it, you have maximum score in your exam. If you spend day and night look at subject and you get the D, then you cannot be interested. And so I spent very little time, and I can remember what I read. And the next to that was physics and math. Because those courses were rather easy.
Yeah, and then in the late 50s, you went from Taiwan to Michigan.
Yes.
With, guess what, $100 in your pocket.
Yes.
Right?
Yes.
So this is a story I think many of us can relate to. Those of us who came to the U.S. as international students. When I came to U.S. on my way to Cornell, I had $35 in my pocket.
Whoa.
Yeah.
Worse than me.
Well, $100 in the 1950s was worth a lot more. But what was your experience like coming to the U.S. to study first engineering and then transfer into physics? What are the challenges? And basically, I think I want to know your secret of success as a student and then as a as a scholar, right? For domestic and international students in this room.
So I remember very clearly, September 6, 1956, I took Northwest Orient Airline from Taipei to Okinawa, to Tokyo, to Alaska, to Seattle, to Minneapolis, to Detroit. Because at that time, the planes...
A lot of frequent miles.
Zero frequent miles. At that time, planes doesn't go for a long distance. And I had no concept of what money is. And I have read that people in the United States normally don't take money from their parents. So I told my parents, I don't want money from you. My mother said, no, you should take at least $100. It's not that they cannot afford it. It's my decision not to take it. But then I realized there was a terrible mistake. Because when I landed in Detroit, at that time, it's a well-run airport outside, not too far from Ann Arbor. And then in the airport, I ate a hamburger. It cost $1. Then I began to realize, gee, I will not last very long. And I went to see the Dean of Engineering. The Dean of Engineering know my parents because my mother was the president of the University of Michigan Alumni Association in Taiwan. And so my mother and my father know the dean. And Dean Brown said, you are in the engineering school. And where do you stay? I said, I do not know. He said, we have a big house. Why don't you come to stay with us? You don't have to pay anything. So I went to stay in their house, and they were very, very kind to me. And by staying with them, I began to learn the custom, the way of conversation, and also the visitor to the family normally are very successful industrialists and engineers. In my first term, I studied mechanical engineering. End of the first term, I went to see my advisor, Robert White, a very famous engineer. He took a look at my grades. He said, no, you are no engineer. Because at that time, that was before computer, and so you have to do engineering drawings, looking from the top, looking from the side, looking from the end. And I couldn't draw a line straight. And he said, why don't you study physics and study math? And why don't you take courses in graduate school? That was my second semester. He said, I'll help you to skip all the humanity courses.
But you're back now.
And we got you back here.
Yeah. And, so in the first term, I was 20 years old. I was the oldest in the class. Second term, I became the youngest. So I took courses in the graduate school, in differential geometry, in topology, all the advanced courses. But the university was really very nice to me, and managed to get rid of me very quickly. And they decided I don't have to take the humanity courses, and also said, you really don't have to take the qualified exam. And in December 23rd, 1962, my advisor, who received the Nobel Prize the same time as Professor Reines, called Marty Pearl, said, now there's a Christmas vacation. Be sure, spend this vacation, write your thesis. Make sure it's less than 40 pages. And be sure to graduate. Be sure to hand in before the end of the year, namely 7 days. And so I managed to do that because with 40 pages you can put in a lot of drawings. And after I got my degree, he said to me, the best physics school department at that time was Columbia. And they had Professor Rabi, who received the Nobel Prize for MRI, and Charlie Towns for the invention of laser, T.D. Lee for parity, many, many famous people. And so I went there, and that's how I started my career.
By the way, a reminder to the audience, if you skip humanities classes, that does not mean that you're going to win a Nobel Prize.
Yeah. Well, you loved Chinese history. Did you miss it? Did you miss the humanities courses? Come on.
I eventually decided perhaps I'm not good enough to study history because in the Chinese dynasties, whenever there's a change of dynasty, the first thing they do is to rewrite the record.
Mm-hmm. That's right. Yeah.
And so there are many versions. So it's very difficult to find out the truth. But I'm still very interested in Chinese stories. Mm-hmm. Yeah. My parents come from a province in China, in northern China, called Santong Province. Yeah. Confucius' hometown, but the people in that province are normally very tall, very strong, and perhaps not known for their intelligence. Because most of the famous bandits in Chinese history come from that town, or come from that province.
So let's move forward to 1976, when you won the Nobel Prize. 3 days after the news was announced, the happy news, wonderful news, a physicist called Richard Feynman of Caltech sent his congratulations to you and jokingly challenged you to make a discovery that he could understand. So can you tell us another new discovery that you've made and its significance, its value, in terms that historians like me could understand?
Let me first mention to you why he wrote such a letter to me. In 1948, he together with Julian Schwinger and Tomonaga formed a theory called quantum electrodynamics. And there, electrons has no measurable size because it's wave-like. So the theory was proved correct, and so later on they received the Nobel Prize. In 1965, some famous professor in Harvard found no, the electron has a size, and they measure the size. And that, at that time, in the 60s, was a very important subject. And that measurement also later on was confirmed by Cornell University. To use very high energy light to see whether you see the size of the electron. So there were 2 experiments confirming Feynman was wrong. I did an experiment with a different method and showed no, Feynman was right. The electron has no measurable size. And since that day on, I began to know him. Okay, that's why he wrote, we have communication often. He's a very, very intelligent person. And he wrote a congratulation telegram to me. It contains 2 things. First, is don't let the pride get into your head. And that is why I almost never sign any petitions on public issues. Many Nobel Prize winners sign things, and I consider myself incompetent to do that. So I never sign anything, since I don't understand. And second thing is, I challenge you to discover to discover something I understand. I don't know how to answer that. And when he was alive, before I carry on an experiment, I often go to see him. The last time I saw him, he was quite sick. I went to Caltech to see him. He came out of the hospital. We had an afternoon conversation. So I explained to him what I'm going to do. And I asked him what he think. He said, "What else are you going to do if you don't do that?" That was good enough for me.
Thank you.
Yeah, I saw some of the interviews, and you talk a lot about, really like the precision and the error-free. That's very, very important in sciences. And then you always check, recheck, double, triple check many times to make sure there's absolutely no mistake. And yet we're in arts and humanities. Mm-hmm. Very often we talk about ambiguity, paradox, liminality, and all these gray areas, which has no right or wrong or black and white. It's a total different kind of approach to subjects, the subject of your research. Do you think these two different kinds of approach have any kind of fruitful conversation between these two approaches? Do you think there's kind of cross-fertilization or mutual benefit?
I'm really not qualified to answer that. I've always make sure my instrument is correct. So I spend enormous amount of time checking the instrument. Before I experiment, I always try to build the instrument as good as possible, as precise as possible. And, now the experiment in space, I have an international team of 15 countries. Before any publication, we always have 2 or 3 countries from one group and the other 2 or 3 countries from it. Analyze the same data from a different group. Because when you have an error that's very small, what is the signal, what is the background, is a judgment call. And only when the two agrees, then we publish the data. So I spend enormous amount of time thinking carefully, who did what, why is that? The thing you asked is too advanced for me.
Maybe you can shift gears a little bit. Back to physics. So
Yeah.
I think at one point you were first interested in theoretical physics and then moved on to experimental physics. And in that shift, I think you had in your mind a dichotomy between theory and experiment, between the use of mind and the use of hands. And this is also a debate that took place in the first part of the 20th century in China, right? A debate over the primacy between between action and thought, between knowledge and doing things. So could you elaborate on that? Which is more important, to have the knowledge or to do experiments?
There is a general misconception that if you are good with your hand, you can do experiments. If you are good with your hand, you are a technician. You are not an experimental physicist. All the great experimentalists I know in 20th century, 21st century, all of them knows a great deal about theory. The fact that you know how to use your hand is totally useless as an experimentalist. I started try to learn theory because I had good grades. And so, like most of the people who have good grades, think they should do theory. My advisor was George Uhlenbeck, who was the one who discovered electron has a spin. So after two months with him, he had a meeting with a few of his students. He said to me and to all of us, if he would live his life over again, he would rather be an experimentalist than a theorist. And he was one of the great theoretical physicists in early 20th century. So I asked him why. He said, experimentalists measure something, therefore it's new. A theorist, you can count on your hand in 20th century how many of them have truly made a difference. And you began to count less than 10 or so. After this little conversation, I went out of his office, took a walk, then come back to see him, said, "You're right, I'm leaving you." And that's how I become an experimentalist. That's how I become an experimentalist.
Yeah. So we designed today's event as your Asian/American journey.
Yeah.
Because we're thinking about identity is fluid in this stage, and then also you have both Asian and Asian American experience. We have a lot of Asian and Asian American students on campus.
Yes, it's obvious.
Yeah, and then I can imagine when you arrived in Michigan, it was probably very few Asians there. And so just think about your own experience, maybe some struggle. And I know a lot of students here are, see you as a role model. Do you have some words of encouragement for them or any kind of advice for them?
When I arrived in Michigan, there were very few foreign students. 1956, very few. Fewer people from Asia. Many of the few Asians tend to group together because of language, food, and culture. I thought it somewhat differently. I realized if I want to stay in the United States, I need to learn the way of living, the way of thinking of the majority. Okay. And so, fundamentally, I spend most of my time, besides working, and go to be associated with most of the rest of the students.
You say you never missed a football game, right?
Yeah. That's right. My first game was with UCLA. And I go to football game, go to hockey, go to basketball game, and sometimes I'll try to skip class just to go to games. Because if you decide to stay in a society, you should respect the existing customs. That's how I decided I should try to learn, not just try to group myself in the minority group.
In 1976, when you gave the Nobel Prize acceptance speech, you made a very interesting decision. That is to do it in Chinese. And so what motivated you to make that decision? And did you encounter any questions or even pressure? Hey, China is our enemy. Don't do that.
At that time, the relationship between the United States and China are not good. There's no relationship. So when the Swedish newspaper asked me, why you are American, why do you want to give your speech in Chinese? Do you have a political intention or implication? And I said, no. Chinese language and Chinese writing is one of the oldest in the world. And there had never been a Chinese speech. And that's the reason I want to keep it Chinese.
That's humanities, by the way, yeah.
The second reason was the content. Because when I was growing up in China, like you have said, people look down on people using their hand. I think people can think is much more superior than people use their hand. And particular students from Asia. And that's why I use the Chinese language to express my reservation about this concept.
So right now we're actually in education, very often people talk about head, hands, and heart. And then the heart is where the arts and humanities are. So I have one more H there. I want to ask you, so in your long career, or maybe earlier in your career, have you encountered anything that it was just so difficult, almost make you give up? Right? Just this is not me. I'm not gonna go into this field. Was there anything like that? If there was something very difficult and then you persisted and overcome that difficulty, so this will be also something to share with our students.
Well, I have been doing experiments in accelerators for many years. And then in the early 1990s, the United States was going to build a big accelerator, about 87 miles in circumference in Texas, called SSC, Superconducting Supercollider. And so I made an enormous amount of effort to propose experiment there. And there were physicists mostly from Europe, from Soviet Union, working with me. Then the Congress canceled SSC. I think probably due to incompetence in the project management. And so then suddenly my career come to a stop. So one day I was walking in the garden. I thought, gee, maybe it's time I I should do something different, something new, something nobody has done before, and something nobody thinks is possible. That's why I thought about put a particle physics detector into space. But I did think through carefully how to do this.
And you mentioned other walks. So is that where you take a lot of walks? But that's how you think?
Yeah, I normally take walks.
Yeah.
So you're one of the most influential scientists of the 20th century of our world, and you've crossed many national boundaries. So let me combine these two elements and turn them into a question. Does science have national boundaries?
Not in my mind. In this experiment I'm involved now, and also the one before that, particularly the one before that, we have collaborators from East Germany, West Germany, from India, from Pakistan, from China and Taiwan, and from many, many countries. So normally when I have a discussion with my collaborators, it's only on physics. So I don't discuss things I don't understand. So then there was no problem. Never had any problem because of nationality or political differences, because I don't get myself involved in that.
So how are we doing with time? We need to leave 10 minutes for this.
Yeah, so maybe the last question?
Last question.
Okay. I just want you to tell us a little bit about what do you see in the future? What would you like science to achieve in the future? What's the biggest wish you have for humanity, yeah.
I do not know how to answer that, but if you think less than 200 years ago, everybody think the earth is flat and we're in the center of the universe. After 200 years of research, we realize the earth is not flat and all existence is a very small part of the universe. So if you don't do research, you will never know.
That's right. Thank you so much.
So much, thank you. Yeah, thank you. Yeah. So we will open up for questions. Do we have mics in the audience? Okay. Yeah.
I can run the back. Nope.
Are we going to start right here?
Yeah, just one
Okay,
over.
sure. Yeah.
Yeah, I had a physics question about when you discovered the J-psi, and then you had the competing group with Burton Richter at SLAC. How fast was that competing group discovered? Did they have to rerun? Did they have to continue running their experiment, or did they just go back and look at old data? And then also, did you have a good relationship with Burton Richter after that? Did you?
Yes. Most of the Nobel Prize winners, some of the Nobel Prize winners, when they received the prize, before they received the prize, their friends, afterwards, they changed their mind. But in my case, Bert Richter and I maintained to be good friends throughout this last 40 years. I think he passed away a few years ago. Bert Richter is really a very, very good physicist. So hope this answered you.
Hello.
Identify yourself, your name, your major.
Oh, my name is Chris, and I'm a first year at UC Irvine. My major is quantitative econ, and I'm also, as Chinese international students, we also share the similar identity and experiences. It's our pleasure to have you over today, and to inspire and motivate the younger generation. So may I ask you, what are some of the most exciting areas of physics you see emerging in the near future? And are there any new technologies or experimental techniques that you believe will revolutionize the field of particle physics in the coming years?
Remember what I said, what Feynman said to me, do not get the Nobel Prize taking over your judgment. So the answer to your question is I do not know.
Hi, I'm Freeman from. I'm a third year PhD student from biochemistry major. I would like to ask you a question that maybe a lot of my classmates or the lab mates have. So how do you know your project will be successful when you face a failure or when you have no progress for a long time?
This has not happened to me yet. But in doing experiment, okay, you really need to make a determination. This is the most important thing in your life. So I never do two experiments at the same time. I never collaborate with anyone who have another project. So spend all my effort on one thing only.
Okay. Thank you so much.
Wow. Hello, Professor Ting. Thanks for your sharing today. My name is Siwei Hu. I'm from China. I'm a fourth year PhD student in Civil and Environmental Engineering department. I have a question. Do you believe in God? What's your view towards faith and science? Are they conflict or are they compatible?
What would you say?
Science and religion.
First
of all, do you believe in God? And then are science and religion like compatible? And faith. Yeah. Faith. Yeah.
I do not know how to answer that. Yeah. I really do not know. I understand what you're asking, but I really do not know how to answer that. You need to know I spend most of my time in the lab.
Okay, very focused.
Okay, please, yeah.
Hello, Dr. Ting. Thank you for your time today. My name is Colin Bullock. I'm a second-year quantitative economics student, and I'm curious as to, it seemed in your story that your parents left Michigan out of a sense of purpose for what I presume was their home country. It seems to me that sense of purpose was also present in their going from China to Taiwan. My question is, what is your perception of the interaction between why your parents went back to China and later to Taiwan? What was your perception of that growing up? How did that interact with your education in Taiwan and then later upon your decision to return for education in Michigan?
Your question is very interesting. But my parents and I live in different generations. They have their background, they have their environment, they have their decision. For me, unfortunately, when they made a decision, I was only 3 months old, so I had nothing to say. And I'm not sure their decision was correct. That doesn't mean they're wrong. I just don't know.
Hello, Professor Ting, and I'm Lucas, first year sophomore from electrical engineering. And I would like to ask you a question that what is your view on quantum entanglement and free will? Because I think the emergence of quantum mechanics propose a kind of challenge on determinism, while I think the quantum entanglement, sometimes it seems like some kind of proof of determinism. And I would like to know what is your view?
I have no view. As I mentioned, okay, I normally do not think myself qualified to answer this kind of questions.
Hi, Professor Ting. I'm a first year student in UCI, and I'm also from China. And I learned econ, so I don't learn physics, but I read an article in my public school. It's called 应有格物致知精神. It's impressed me a lot. Also, I think it's used by the public middle school now in China. So I have a question about
Can you translate the title?
It's called 应有格物致知精神.
Right. So can you translate the title?
It's maybe about the spirit of research and face to the challenge. Yeah, and I have a question about the article. Do you think it's useful? Do you think the Chinese culture is helpful for your scientific learning or research?
So it's a 格物致知,
Yes. Yes. That's part of my speech in the Nobel Prize ceremony. Obviously, this view contradicts with traditional Chinese views. And basically, it implies that people who has mind control people who use their hand. And I do not know how much my background in China influenced me. This I do not know. People changes all the time. Depends on the environment, depends on what physics phenomena you have observed, and how you think about the next experiment. So I do not know how to answer that.
Here.
Hi, Dr. Ting. So,
You need to speak louder.
hi, Professor Ting. So I'm a third-year informatics major student, and you mentioned that you changed your major for several times. You changed from engineering to physics, you changed from change to experiment physics. So I think that's all important life choices. Can you share your thoughts before you do those life choices?
Share my thoughts.
Before you what do you think before you do those life choices?
I would think instinct.
Yeah. How did you make those choices?
I have no idea. Once it's made, it's made. When you conduct an experiment with hundreds of people, you make decisions every day. Sometimes difficult decisions. But you just make them and forget about it. But before you do that, it's better you think through very carefully.
Mr. Ting, it's Chris again. I know you have collaborated with NASA and you have launched rockets. And do you see any indications of aliens after you, after exploring space, after all those activities?
I don't know how to answer that. You are not talking about theoretical physicists.
So you haven't caught any aliens so far?
But I do want to agree with you that I've met many physicists over the years, and some of them are a little bit strange.
Do we have any humanities questions or arts questions? Come on. Oh yeah, go ahead. Yeah. Okay, I will have one here. Yeah.
An art and humanities question. You spend most of your time thinking about physics, thinking about your experiments. In the little free time that you have, is there an artist or a book or a writer or a play or something that you particularly enjoy that you would like to share with us?
There is a Chinese book. In Chinese name, it's called Liao Zai.
It's a collection of ghost stories.
Aliens there.
I admire the author. The author has imagination.
Right.
Incredible imagination. Yeah, I actually went to his hometown together with my wife to take a look at his hometown. Yeah.
Where is it?
In Shandong province.
In Shandong.
I love that way too.
Okay.
Hi. I'm Professor Ting, and I'm Sitao Huan. I'm a first-year assistant professor at UCLA. So I'm from Department of Electrical Engineering and Computer Science. So my question is related to engineering. So we have seen that people are building supercomputers. So computers are becoming faster and faster, and it has already revolutionized the completely changed landscape of AI, so AI, artificial intelligence. And for recent years, and we are seeing great development in AI. Could you comment on how the advancement of computing is helping or working together with future of physics, and also what is the role also of AI in science and especially in physics? Thank you.
I would imagine advancement of computing, AI is extremely important. No question about that. This World Wide Web was developed by CERN because we need fast transmission, fast analysis of data. But I suspect AI cannot replace creativity. I don't think quantum mechanics or relativity will be invented by AI.
Hi, Dr. Ting. My name is Sana, and I'm a first-year undergraduate physics student. And could you give any recommendation on research and path to pursue research? And how do I locate my research field? And do you have any suggestion about to being a physics student? What kind of skill sets or learning strategies do you think is very important?
As a freshman, you probably should be interested in everything and gradually focus on a selected topic. The later you make the decision, the better you are. Then you know more things. no need to make a decision quickly.
Here is one first. Yeah.
So, my name is Claire Yu. I'm a physics professor, and I want to thank you, first of all, for a fascinating conversation and for coming to UCI. I think we've all been enriched by that. I have a quick question. What wasn't clear to me was you went to Michigan as a undergraduate.
Yeah.
Did you leave with a PhD, or what degree did you leave with? And when you went to Columbia, were you going as a student or faculty member? That just wasn't clear to me.
I entered University of Michigan in 1956 as a freshman. And then in 1959, I received a bachelor's degree in mathematics and in physics. 1960, received a master's degree in physics. 1962, PhD in physics.
From Michigan.
Yes. But unfortunately, I don't think I have any of the diplomas anymore. Because we'll be moving a lot, and I certainly couldn't find the diploma.
So you went to Columbia as a faculty?
Yes, as a faculty.
Hello, Professor Dr. Ting. I'm a fourth year. My name is Ben. I'm a fourth year physics undergrad. I wanted to ask, is there anything that you've done in your scientific career that has profoundly changed how you see the world?
Profound change of what?
How you see the world.
No, how I see the world, at least in my very limited area, changes from one experiment to another. To the general world, no. I normally just concentrate on my experiment and think of nothing else.
All right, thank you.
Professor Ting is Siwei again, a fourth year PhD student in civil engineering. I'm wondering, what's your, you are a very successful physicist. What's your definition of success? And what's the path what's your path towards success and your suggestions for students?
This I do not know. People often ask, why you have done many experiments, why you still continue? Why you don't retire? The answer is very simple. I'm interested in what I'm doing. I'm curious about what I'm doing. So I hope this answered you.
Hi, Professor Ting. This is Yin Zhang. I'm here.
Oh, yeah.
Yeah, we're here. This is Yin Zhang. I'm the research librarian at this university. I had a bachelor degree in bioscience, and also I got the PhD in information studies. So I kind of combine the science and the social science or whatever. But my question to you is, I am always a big believer of science is an art. So when
Science
is an art. Because it's a creative work. That's first, and also the second, the topic, your research project comes with a like explosion in your mind. I guess some similar to the artist when they want to create something. When you, as a scientist, you want to do some discovery. I think I'm trying to link the two fields. You know, when you design an experiment, maybe there are several choices, different methods. Which one you pick, you need to make your own decision based on scientific, of course, but also your personal, I would say, preference or your instinct you just mentioned in your research. So I want to ask you your idea about science as an art in your own way.
You ask a very important question. Once you choose a physics topic, what kind of detector you design? to achieve this goal. I can only say for me, I always try to choose the most precise detector. Try independent how difficult it is. And a good example is in 1983, I started experiment in Geneva. This experiment uses a special crystal called BGO. It has a density of stainless steel, but it's totally transparent. At that time, that's the best detector to measure light. At that time, the world's production was 4 kilograms per year, and I need 12 tons. And so I proposed this and received total objection from the community. So this cannot be done. And I managed to have it done in 3 years. So I don't think it's art, but the intuition is important. You should never, never, never compromise on your instrument.
Yeah, maybe I can ask a follow-up question, because I remember you talk about there are all these proposals, right? People don't believe you, and then you talk to somebody, and then you convince them to fund you, and so you do all that kind of thing. So I guess rhetoric will be very important, right? Rhetorical skills for a scientist will be very important, right? To think about how you can convince people, how you can propose something, and people will believe you.
What you said, of course, is true, but even more important is people look at your record, what you have done before, what instrument you have done. Have you ever made a mistake? What is your experimental result means? Those are actually a good group of people judge you. They should look at this record. Record is really the most important thing, because there's no bias on that.
Right. Maybe two. Okay. Okay.
Hello, Professor Ting. I was quite surprised you said you went to every football game. What do you do at the
Yes.
What do you do at the football game, and what other clubs do you join?
What do I do in the football game? Watch where the ball moves.
What other clubs did you join?
No, you go to football not to join a club. You just go there to watch.
Yeah. Did you?
I mentioned I watch hockey in winter time. Okay. In spring, basketball. In the fall, football. Yeah.
But how do you socialize? How do you socialize in the game? Like, you talk to people?
Yeah, I do talk to people, particularly when we won.
You still watch football? You still watch football?
Oh yes, absolutely. Particularly Michigan and Ohio State.
Okay, one last question. Yeah.
Hi, Professor Ting. I'm Jasmine, and I'm here at U31. I'm the freshman here, and I study mathematics. So basically, all my homework is like to do some calculating again and over again. Like, I think that is pretty boring. Like just do some mathematical rules. And I hear that you transfer from the theoretic physics to experimental physics. And I just want to ask, do you think to find a theory is more important, or doing a good experiment is more important?
Both are equally important. Both are equal, but a theory cannot disprove an experiment. But if a theory disagrees with the experimental result, then you need a new theory. That's the difference.
That's true.
My name is Nikhil Shah. I'm actually an attorney. I was a physics major as an undergrad. But I just have a question about science communication. I know that when Kip Thorne and Barry Barish won the Nobel Prize, one of their biggest things post winning the Nobel Prize was communicating science to the public, and they have certain theories on how to do it with patients. I was wondering if you have similar ideas about communicating complex concepts to the public?
No. No, I don't. Okay. So am I free now?
Almost, yeah, yes. Thank you so much.
Thank you very much. Yeah. Thank you.